So today let us see questions related to conicoid, and that specifically questions related to ellipsoid. Paraboloid questions we'll see later someday. So the question 1 says that P, Q, R, P dash, Q dash, R dash are feet of 6 normals drawn from a point to this ellipsoid. So let capital A, x1, y1, z1 be any point, and a normal is drawn from point A to this ellipsoid. So my ellipsoid is basically x square by a square plus y square by b square plus z square by c square equals to 1. So a normal from A is drawn to this ellipsoid, and the normal has basically 6 feet, and those feet are represented by P, Q, R and P dash, Q dash and R dash. So the question further says that the plane PQR is represented by this. So my plane P1 is basically Lx plus My plus Nz equals to P. So if you observe that the plane PQR will be passing via point P, Q and R. So this plane has 3 feet of normal. 3 feet of a normal passing via x1, y1 and z1. So question further says that we are supposed to show that the plane P dash, Q dash, R dash is this. So our claim is P dash, Q dash, R dash is basically plane x upon a square L plus y upon b square m plus z upon c square n plus 1 by p is equals to 0. So we are supposed to show that the plane P dash, Q dash, R dash is this plane. So let us write equation of normal passing via x1, y1, z1. So equation of normal will be x minus x1 upon x1 by a square is equals to y minus y1 upon y1 by b square is equals to z minus z1 upon z1 by c square. So if this equation of normal is passing via point alpha comma beta comma gamma, then it will be basically alpha minus x1 upon x1 by a square is equals to beta minus y1 upon y1 by b square is equals to gamma minus z1 upon z1 by c square. So if this is equals to, let's say, lambda, then from here I can find out value of point x1, y1 and z1. So if I solve this, I'll get alpha is equals to x1 into 1 plus lambda by a square, beta equals to y1 into 1 plus lambda by b square, gamma equals to z1 into 1 plus gamma by c square. So if I equate it, I'll get x1 as alpha a square upon a square plus lambda, y1 as beta b square upon b square plus lambda, and z1 as gamma c square upon c square plus lambda. So these are basically my points of x1, y1, z1. And since we have taken normal at point x1, y1 and z1, so it must be lying on ellipsoid. So using that logic, I'll get 1 upon a square into alpha a square upon a square plus lambda square plus 1 upon b square into beta b square upon b square plus lambda square plus 1 upon c square into gamma c square upon c square plus lambda square is equals to 1. So if you see that this is basically a equation of 6 degrees. So from here we'll get 6 values of lambda, and those 6 values of lambda will basically give me 6 values of x1, y1 and z1, and those will be basically foot of perpendicular via point, foot of normal. So from here I'll get basically 6 values of lambda because it is a 6-degree equation, and that will give me basically 6 foot of normal. So the question says that PQR has 3 foots of normal. So LX plus my plus nz equals to P has 3 foot of normal. So if I substitute x1, y1, z1 here, so I'll get L into alpha a square upon a square plus lambda plus m into beta b square upon b square plus lambda plus n into gamma c square upon c square plus lambda is equals to P. So because in the question it says that 3 foot lies on this equation, and this will basically give me a cubic equation in lambda, and those 3 values of lambda will give me 3 foots of normal. So now let us assume that P dash Q dash R dash be plane L dash x plus m dash y plus n dash z is equals to P dash. So 3 foots that are basically P dash Q dash R dash must be lying on this plane. So this plane must be satisfied by x1, y1 and z1, so that we can find out other 3 foots. So that is basically beta b square upon b square plus lambda plus n dash gamma c square upon c square plus lambda is equals to P dash. Let us name it as 2 and let us name this as 3. So from 2 and 3 I got 2 cubic equation, and if I take product of these 2 and 3 equation, I'll basically get the equation 1. So if I do so, if I compare 2 into 3 with basically 1, so we'll basically compare the equal coefficients. So I'll get alpha square a square upon a square plus lambda square, and if I multiply 2 by 3, so the coefficients of a square plus lambda whole square will be basically alpha square a raised alpha square a raised 4 upon a square plus lambda square into L dash. So likewise, if I compare terms with b square plus lambda square, I'll get beta square b square upon b square plus lambda square is equals to beta square b raised 4 m dash upon b square plus lambda square, and gamma square c square upon c square plus lambda square is equals to gamma square c raised 4 n dash upon c square plus lambda square. So from here I'll get my L dash as 1 upon a square L, likewise my m dash as 1 upon b square m, and n dash as 1 upon c square n. Also from here, if I multiply 2 and 3, my constant term will be basically p dash, and in 1 my constant term, if I take this term on left hand side, it will be minus 1. So if I equate these two, I'll get my p dash as minus 1 by p. So basically I got the value of L dash, m dash and n dash and p dash, and I can substitute in the plane which we have assumed, that is star. So if I substitute value of L dash, m dash and n dash, I'll get x upon a square L plus y upon b square m plus z upon c square n is equals to minus 1 by p. So which can be simplified as x upon a square L plus y upon b square m plus z upon c square n plus 1 by p is equals to 0. So this is basically my equation of plane p dash, q dash and r dash, which contains 3 feet of normal. So now let us move on to next question. So the question number 2 says that find the equations of tangent plane to ellipsoid which passes via line this. So the given ellipsoid is 2x square plus 6y square plus 3z square is equals to 27. So if I reduce it in a general form, it will be x square upon 27 plus 6y square upon 27 equals to 3z square plus 3z square upon 27 is equals to 1. And the question says that my tangent plane passes via given lines that are basically x minus y minus z is equals to 0, which is equals to x minus y plus 2z minus 9. So the equation of any plane passing via these lines will be of form x minus y minus z plus lambda into x minus y plus 2z minus 9 is equals to 0. So if I simplify it, I'll get x into 1 plus lambda plus y into minus 1 minus lambda plus z into minus 1 plus 2 lambda minus 9 lambda is equals to 0. So let us name this as star. So we are supposed to find the value of lambda for which this star is basically tangent to a star dash, that is the equation of ellipsoid. So here we can use basically the tangency condition that says L square by A plus M square by B plus N square by C must be equals to P square if Lx plus My plus Nz is equals to P is my tangent plane, and the equation of ellipsoid is Ax square plus By square plus Cz square is equals to 1. So if I equate it and substitute value of Lm and ABC, I'll get 1 plus lambda square upon A is basically 2 by 27 plus minus 1 minus lambda square. B is basically 6 by 27 plus minus 1 plus 2 lambda upon 3 by 27 is equals to P square, and my P is 9 lambda square. So if I simplify it, I will get 1 plus lambda square plus minus 1 minus lambda square by 2 by 6 plus minus 1 plus 2 lambda square by 3 is equals to 9 lambda squared by 27. So this can be further simplified. We can take 6 as LCM on left hand side, so I'll get 3 into 1 plus lambda square plus 2 lambda plus 1 plus lambda square plus 2 lambda plus 2 into 1 plus 4 lambda square minus 4 lambda is equals to 9 square is 81 divided by 27 is basically 3 lambda square into 6. So this can be simplified as 4 plus 4 lambda square plus 8 lambda plus 2 plus 8 lambda square minus 8 lambda is equals to 18 lambda square, which is basically equals to 12 lambda square. This 8 balances out the negative one, plus 6 equals to 18 lambda square. So from here I'll get 6 lambda square is equals to 6, which is basically equals to lambda square equals to 1, and from here I'll get two values of lambda, that is plus 1 and minus 1. So we have basically two planes passing via the given lines which are tangent to the given ellipsoid. So the equation of plane is basically when my lambda is 1, so equation of plane is 2x minus 2y plus z minus 9 is equals to 0, and when my lambda is basically minus 1, the equation of plane is 0 into x plus 0 into y minus 3z plus 9 is equals to 0. So which is basically z minus 3 is equals to 0. So we have basically two planes of equation, two equation of planes which are tangent to the given ellipsoid and passing via given lines. So let us move on to next question. So the next question says that let P be vertex of enveloping cone to the ellipsoid this. So let P be my x1, y1, z1 and its vertex to enveloping cone of x square by a square plus y square by b square plus z square by c square is equals to 1. So equation of enveloping cone will be, so it will be basically s1 is equals to t square. So if I write it, it will be x square by a square plus y square by b square plus z square by c square minus 1 into x1 square by a square plus y1 square by b square plus z1 square by c square minus 1 is equals to x1 by a square plus y1 by b square plus z1 by c square minus 1 whole square. So this is basically my equation of enveloping cone with x1, y1, z1 as its vertex. So the question further says that if the section of this cone is made by plane z equals to 0, so this is section by plane z equals to 0, then it is giving us a rectangular hyperbola in xy plane. So if we substitute z is equals to 0 here, and we'll get x square by a square plus y square by b square minus 1 into x1 square by a square plus y1 square by b square plus z1 square by c square minus 1 is equals to x1 by a square plus y1 by b square minus 1 whole square. So equation says that this section is basically representing a rectangular hyperbola. So if it's a rectangular hyperbola in xy plane, then a coefficient of x square plus coefficient of y square must be equals to 0. That I mean the sum of coefficient of x square and coefficient of y square must be 0. So if from star I can find out coefficient of x square and y square, so then we'll get basically locus of the point P. So the coefficient of x square will be 1 by a square into x1 square a square plus y1 square by b square plus z1 square by c square minus 1, and from right hand side it will be minus of x1 square by a raised 4. So this is basically my coefficient of x square, and likewise my coefficient of y square will be 1 by b square into x1 square by a square plus y1 square by b square plus z1 square by c square minus 1 minus of, from here I will get coefficient of y square as y1 square by b raised 4. It must be is equals to 0. So if I simplify it, I will get y1 square upon a square b square plus z1 square upon a square c square minus 1 upon a square plus x1 square upon a square b square plus y1 square upon b. This will be balanced out via this term plus z1 square upon b square c square minus 1 upon b square is equals to 0. So if I simplify it, I will get x1 square upon a square b square plus y1 square upon a square b square plus z1 square upon c square into 1 by a square plus 1 by b square equals to 1 upon a square plus 1 by b square. So locus of vertex P, that is x1 y1, z1 is basically x square upon a square b square plus y square upon a square b square plus z square upon c square into 1 by a square plus 1 by b square, which is equals to 1 by a square plus 1 by b square. So this is basically the locus of required vertex of enveloping contour the given ellipsoid. So let us move on to next question. So the next question says that find the length of normal chord passing via point P of the ellipsoid. So let's say alpha comma beta comma gamma be any point on ellipsoid, and that ellipsoid is basically x square by a square plus y square by b square plus z square by c square is equals to 1. So alpha beta gamma is basically any point on the ellipsoid, and we are supposed to find the length of normal chord passing via this point P to this ellipsoid, and prove that if it is equals to 4p G3, where G3 is point where the normal chord through P meets xy plane, then P lies on this cone. Okay, so if let's say this is my equation of ellipsoid and this is some point P, then this will be basically my normal chord where it will intersect ellipsoid at another point, let's say Q. So let us first find out equation of normal passing via point P. So the equation of a normal chord will be x minus alpha upon a square is equals to y minus beta upon beta by b square is equals to z minus gamma upon gamma by c square. But in normal form it will be basically x minus alpha upon alpha by a square into p is equals to y minus beta upon beta into p by b square is equals to z minus gamma upon gamma into p by c square, and where my p is basically alpha square by a raised 4 plus beta square by b raised 4 plus gamma square by c raised 4. So P is basically satisfying this. So if I assume that let's say R is basically distance between point P and Q, then if I equate it with R, then from here I will get basically arbitrary basically parametric form of point Q. So my point Q will be alpha plus R alpha P upon a square beta plus R beta P upon b square comma gamma plus R gamma P upon c square. So this is basically my point Q, and since it is the another point where the normal is cutting the ellipsoid, so this point Q must be lying on the given ellipsoid. So using that, if I substitute this value of Q in the given ellipsoid, I'll get 1 by a square into alpha plus R alpha P upon a square whole square plus 1 by b square into beta plus R beta P upon b square whole square plus 1 by c square into gamma plus R gamma P upon c square whole square is equals to 1. So if I simplify it, I'll get basically a quadratic equation in R square. So that will be alpha square P square upon a raised 6 plus beta square P square upon b raised 6 plus gamma square C square upon C raised 6 plus 2R into 2R will give me alpha square P square upon a raised 6 plus gamma square C square upon C raised 6 plus 2R into 2R will give me alpha square 2 square upon 2 raised 6 plus 2R into 2 raised 6 plus 2 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 into 2 raised p upon a raised 4 plus beta square p upon b raised 4 plus gamma square p upon c raised 4. So if I'll multiply it, it will be basically, from here I'll get 2 alpha into r alpha p upon a square, and 1 a square will be this one, so it will be a raised 4, and 2 I have already taken 2r as common, so I'll be left with basically alpha square p upon a raised 4. Likewise here beta square p upon b raised 4, and here gamma square p upon c raised 4, and the constant terms will be alpha square a square plus beta square b square plus gamma square c square minus 1 is equals to 0. But if you assume that if you remember that we have assumed p alpha comma beta comma gamma be any point on ellipsoid, so alpha beta gamma must be satisfying the equation of ellipsoid. So if it satisfies equation of ellipsoid, I'll get alpha square by a square plus beta square by b square plus gamma square by c square is equals to 1. So using this, this term will reduce to 0. So I am left with r square p square into alpha square upon a raised 6 plus beta square upon b raised 6 plus gamma square upon c raised 6 plus 2r into p into alpha square by a raised 4 plus beta square upon b raised 4 plus gamma square upon c raised 4 is equals to 0. So from here I can take rp as common again, so I'll be left with rp into alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6 plus 2 into alpha square by a raised 4 plus beta square by b raised 4 plus gamma square by c raised 4 is equals to 0. So if you recall that this term is basically is equals to 1 by p square, so from here I'll get rp into rp alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6 plus 2 into 1 by p square is equals to 0. So if I solve it for r, so I'll get either r is equals to 0 or r is basically minus 2 upon p cube into alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6. And if you remember the equation of normal, so if I take my r is equals to 0, so my other point q will be basically alpha beta comma gamma, which is the same point as p. But since normal chord will be cutting the ellipsoid at two distinct points, so I cannot take r is equals to 0. So I can easily eliminate this one. So my r will be basically this, that is minus 2 upon p cube into alpha square upon a raised 6 plus beta square upon b raised 6 plus gamma square upon c raised 6, and I have assumed basically r as the distance between p and q. So length of pq is basically, I'll take it modulus of it because length cannot be negative. So it will be basically p cube into alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6. So this is basically my length pq. So in the question it further says that if this length is equal to 4pg3, where g3 is the point where the normal meets the xy plane. So if the normal meets xy plane, then their z must be is equals to 0. So if I equate z coordinate is equals to 0 at xy plane, z coordinate is equals to 0. So if I equate this with 0, that is r plus gamma plus r comma p, gamma plus r comma p by c square, I guess, is equals to 0. So from here I'll get r as minus c square by p. So this is basically the point to G3. So if this is G3, so it says that the length PQ is equals to 4 of PG3. So PQ is equals to 4 of PG3. So my PQ is minus 2 upon P cube into alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6 is equals to 4 into pg3, which is basically minus c square by p. So if I simplify it, this minus 2 will balance out the negative here and 2 here, so I am left with 1 by p square is equals to 2c square into alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6, so, which is equals to my 1 by p square is alpha square by a raised 4 plus beta square by b raised 4 plus gamma square by c raised 4, which is equivalent to 2c square into alpha square by a raised 6 plus beta square by b raised 6 plus gamma square by c raised 6. So if I take it all on right hand side, I'll get alpha square by a raised 6 into 2 square minus a square plus beta square by b raised 6 into 2c square minus b square plus gamma square by c raised 6 is equals to 2 square minus c square is equals to 0. So if I simplify it, I'll get alpha square by a raised 6 into 2 square minus a square plus beta square by b raised 6 into 2c square minus b square plus gamma square by c raised 4 is equals to 0. So this is basically the required equation of cone that we got if we equate the length PQ with PG3. So let's move on to the next question. So the next question says that find the locus of point of intersection of three mutually perpendicular tangent planes to this ellipsoid. So the equation of ellipsoid is ax square plus by square plus cz square is equals to 1. So let us assume any arbitrary plane that is tangent to, let's say, 1. So let lx plus my plus nz is equals to p be tangent to the ellipsoid 1. So if this is tangent, then using the tangency condition, I'll get L square by A plus M square by B plus N square by P is equals to P square. And from here I can find out value of P, that will be basically plus minus under root L square by A plus M square by B plus N square by C. So any equation of any tangent plane to the equation 1 will be of form Lx plus My plus Nz is equals to plus minus under root L square by A plus M square by B plus N square by C. So this is equation of any arbitrary tangent plane to equation 1. So we are supposed to find the locus of intersection of three mutually perpendicular tangent planes. So let us assume that Li, Mi, Ni be direction cosines of three mutually perpendicular tangent planes. and we have just seen that any arbitrary tangent plane to 1 will be of form this. So I can just substitute Li, Mi and Ni for I is equals to 1, 2, 3 to get equation of three mutually tangent planes. Three tangent planes which are mutually perpendicular to each other. So that will be L1x plus L1y plus N1z is equals to under root L1 square by A plus M1 square by B plus N1 square by C. Likewise, equation of second plane will be L2x plus M2y plus N2z is equals to L2 square by A plus M2 square by B plus N2 square by C. We can just take positive values here. We can just eliminate negative here because we are supposed to find only three tangent planes which are also mutually perpendicular. So if we'll take both positive and negative, we'll be getting 6 tangent planes. So the third plane will be L3x plus M3y plus N3z is equals to under root L3 square by A plus M3 square by B plus N3 square by C. So these are basically my 3 tangent planes. So if I take square of both 3 and just add them, I'll get L1x plus M1y plus N1z square plus L2x plus M2y plus N2z square plus L3x plus M3y plus N3z square. It must be equals to L1 square by A plus M1 square by B plus N1 square by C plus L2 square by A plus M2 square by B plus N2 square by C plus L3 square by A plus M3 square by B plus N3 square by C. So we also, if you remember that we have assumed that these 3 planes are basically mutually perpendicular to each other. So using that relation, I'll get my Li Mi summation is equals to 0. Likewise, summation of Li square is equals to 1, and also so if I use this relation here and just open whole square, so I'll be getting x square into L1 square plus L2 square plus L3 square. Likewise, y square into summation mi square and z square into summation ni square plus coefficients of xy will be summation will be basically L1 m1 plus L2 m2 plus L3 m3, and coefficient of yz will be basically summation mi ni, and likewise coefficient of xz will be summation li ni, which must be is equals to 1 by a into L1 square plus L2 square plus L3 square plus 1 by b into summation mi square plus 1 by c into summation ni square. Then using these results herein, I'll get x square into 1 plus y square into 1 plus z square into 1 plus this term will reduce to 0. Likewise, this will also go to 0 and this will also go to 0. So I'll be getting is equals to 1 by a. This will be 1 by b plus 1 by c. So I got x square plus y square plus z square is equals to 1 by a plus 1 by b plus 1 by c. And this is basically the locus of intersection point of these 3 planes. You can also solve it using like the determinant method. That will be basically x, y, z1, and here in coefficients of x1, x, y, z, that is L1, M1, N1, and here this under root L1 square by a plus M1 square b. Likewise here, and if you will equate it with 0, you will basically get the required locus only, but that will be quite time consuming because you're supposed to solve this 4x4 determinant. So this one is a simpler method. So let us move on to next question. So the next question says that show that the line drawn from origin and parallel to normal to the central conicoid dish at its point of intersection with this plane generates this cone. Okay, so they have given us equation of ellipsoid, that is basically ax square plus by square plus cz square is equals to 1, and they have given us equation of plane, that is lx plus my plus nz is equals to p. So let alpha comma beta comma gamma be intersection point of ellipsoid E and plane B. So if this is intersection point of ellipsoid and plane, this point must be lying on equation of both ellipsoid and plane. So using that, I'll get a alpha square plus b beta square plus c gamma square is equals to 1, and alpha L plus beta m plus gamma n is equals to p. So the question says that equation of line drawn from origin and parallel to normal to central conicoid at the intersection point. So if this is the central intersection point, then direction cosines of normal to central conicoid at this point alpha comma beta comma gamma will be basically a alpha, b beta and c gamma. So a line is drawn passing via origin and direction cosines are parallel to these. So the equation of any such line will be x minus 0 upon a alpha equals to y minus 0 upon b beta equals to z minus 0 upon c gamma. So this is basically my equation of any line which is parallel to normal to this conicoid and passing via this. So the question says that we're supposed to show that this line will be generating this cone. So equation of any cone from here we'll get as a alpha square plus b beta square plus c gamma square is equals to 1 square, and from this I'll get my 1 as alpha L plus beta m plus gamma n by p. So using the homogenization method, I'll get my equation of cone as a alpha square plus b beta square plus c gamma square is equals to alpha L by plus beta m plus gamma n by p whole square. So if I simplify it, I'll get p square into a alpha square plus b beta square plus c gamma square, which is equals to L alpha plus m beta plus gamma n whole square. So I can write this equation as, because we are supposed to find the locus, so we need to eliminate these arbitrary points. So for that I'll be multiplying by, I can write it as a square alpha square by a plus b square beta square by b plus c square gamma square by c, which will be equals to L a alpha by a plus m b beta by b plus n c gamma by c whole square. And from here I can easily eliminate a alpha b beta and c gamma, so which will give me my locus as x square by a plus y square by b plus z square by c is equals to lx by a plus my by b plus nz by c whole square. So this is basically my locus of the cone, which is generated via a line passing via origin and whose direction cosines are basically parallel to normal to intersection point of this conicoid and the plane. So let us move on to next question. So the next question says that find the equation of tangent planes to this surface and which also passes via this line. So the given ellipsoid equation is 7x square minus 3y square minus z square plus 21 is equals to 0. So if I reduce it to general form, I will get minus 7x square by 21 plus 3y square by 21 plus z square by 21 is equals to 1. Also the given equation of lines are 7x minus 6y plus 9 is equals to 0, comma z is equals to 3. So equation of any plane passing via the given line will be basically 7x minus 6y plus 9 plus lambda into z minus 3 is equals to 0. So if I simplify it, I'll get 7x minus 6y plus lambda z plus 9 minus 3 lambda is equals to 0. So this is basically my tangent plane to the given ellipsoid star dash. So now using the tangency condition, I'll get 7 square upon minus 7 by 21 plus minus 6 square upon 3 by 21 plus lambda square upon 1 by 21 is equals to 3 lambda minus 9 square. So if I simplify it, I'll get 49 minus 49 upon 7 plus 36 upon 3 plus lambda square is equals to lambda minus 3 square by 21. So I can simplify it, I'll get minus 7 plus 12 plus lambda square into 7 is equals to 3 into lambda square plus 9 minus 6 lambda, which is basically equals to 12 minus 7 5 is 35 plus 7 lambda square is equals to 3 lambda square minus 18 lambda plus 27, which can be simplified as 4 lambda square plus 18 lambda plus 5 plus 3 is equals to 8, which is equals to 0. So it is a quadratic equation in lambda and we can easily solve it. So I'll get 2 lambda square plus it can be written as lambda plus 8 lambda plus 4 is equals to 0. So if I take lambda as common, I'll get 2 lambda plus 1, and from here I can take 4 as common, so I'll be left with 2 lambda plus 1. So which is basically equals to 2 lambda plus 1 into lambda plus 4 is equals to 0. So from here I got two values of lambda, which is minus 1 by 2 and minus 4. So the equation of tangent plane passing by the given lines are basically 7x minus 6y minus z by 2 plus 9 plus 3 by 2 is equals to 0, which is basically 7x minus 6y minus z by 2 plus 9 to 18 plus 3 21 by 2 is equals to 0, and the another equation will be 7x minus 6y minus 4z plus 9 plus 4 3s are 12 is equals to 0, which is basically equals to 7x minus 6y minus 4z plus 21 equals to 0. So these are basically two equations of tangent planes passing via the given lines. So let us move on to next question. So the next question says that a plane makes equal intercept on positive part of axis and touch the ellipsoid this, find its equation. So any equation making equal intercept with positive part of axis will be basically x plus y plus z is equals to k, and here value of k is greater than 0 because the plane is making intercept on positive part of axis and not on negative part. So this is basically my equation of plane, and it touches the given ellipsoid, that is x square plus 4y square plus 9z square is equals to 36. So if I write it in general form, it will be x square by 36 plus y square by 9 plus z square by 4 is equals to 1. So using the tangency condition, I'll get 1 upon 1 by 36 plus 1 upon 1 by 9 plus 1 upon 1 by 4 is equals to k square. So if I simplify it, I'll get 36 plus 9 plus 4 is equals to k square. So my k square is basically equals to 49. So from here I'll get k equals to plus minus 7. But since the plane is making only positive intercept, so we can conclude that our k is only positive 7, and we are negating the value k equals to minus 7. So the equation of any such plane is basically x plus y plus z is equals to 7. Yeah, that's what we are supposed to do in question. So I think we should end this video here because otherwise it's very difficult to upload a long form video. So we'll discuss other questions in next part. So thank you for watching this video.